Hey, Jozak here. I wanted to show you a little bit about the project we're going to be building in the video that follows, which was a live stream from Twitch. Basically, it's a project that will try to clip audio out from files between two loud noises. So in this case, we had a dog click, and we wanted to get rid of that dog click and the noise, the audio that happened between it and the next dog click. Kind of like when a director says action on those old-timey movies. Anyway, here's a project. It's all up on GitHub. You can find a link in the description, and it's a Jupyter notebook, so it looks really nice actually in GitHub, and you can see not only the stuff that we typed up, but actually the execution of this notebook as well. So watch the rest of the video if you want to see how the sausage was made, but I just want to give you a little preview here of the final product, where we basically take this audio file and turn it into this one. All right, hope you enjoy. All right, hey, I think I'm live. Hope you're having a good night. I stuck back on here. Just had a little bit of free time today. I did all my chores. I've been a good boy, so here we are. And I've been messing around with Python lately. I'm trying to learn Python and messing around with pandas and some kind of machine learning stuff. But tonight I just wanted to have a little bit of fun. I had an idea for a project I've been meaning to do for a long time, and so I thought it might be a good way to kind of put some of the stuff I've been messing with to use. And so let's give it a shot. And basically the just is, we got the Coding Box podcast, right? And sometimes we have to take a break or do an ad spot or do something, and so we'll use a dog clicker. In fact, I have it right here. Let's see. I keep it attached to the microphone at all times. We use the dog clicker mainly to like a training clicker. We use this to sync up audio. So we all record on our ends. It's very loud. Yeah. I mean, and it's great because the noise is so loud and it fills up the spectrum really well, but it's also very discreet. It's very fast, so you get like a great hard line in the audio. So what I wanted to do is basically see if I could do something cool, like detecting that in an audio file, and then maybe eventually using that to kind of cut out parts of the audio file automatically. So you can click in maybe once to start and twice to end or something like that. Who knows if I'll get that far? I really don't know. I've never done anything like this with audio files, and so it may be totally miserable. I don't know. But I did a little bit of Googling. I found a Python library for Yay, thank you. Alright, whatever. Something like that. Make it work. Alright, so you sent me Stack Over... Did I lose the link again? Oh my gosh. Thank you. Okay, there we go. Read. Alright. That all looks good. So we open the WAV file, read the frames, blah blah, and we print something like that. All right, cool. So now we need a WAV file.wav. So I was just going to do like sound recorder, something like this. I don't know how this will work since I'm already using the microphone. Well, we'll see. Okay, so that sounds fine. And we'll record from USB, right? That sounds good. Sure. I don't know if it's working. We'll try it. Entering the WAV file, and the program will be creating a plot. Alright, so hopefully we'll be able to see this pretty easily, and you'll see what I mean. So Most audio files that I deal with basically have some sort of talking like this. I can see my signal's a little low, actually. I should bump that up. But we have some sort of talking, but then this. Like, look at that. Do it again. So it stands out very much, you know, at least visually. And it's quick, so it's consistent. I can't have like a long click, really. Yeah, exactly. So I think that this should be a pretty easy thing to do. I mean, it looks like that would not be hard to detect. Like, as far as, you know, machine learning tasks or just tasks in general, like, you know, I can see that pretty easily. There's a wave file, that wave. I forget where I am. Alright. Oh my gosh. Okay, we see this thing here. Yeah, and it's even called wavefile.wave. Oh, I spelled it wrong. I mean, I could also just name the file. Okay, hey, look at that. What's that? Oh, here we go. So now we can kind of just keep this around. A little description here. So, audio files. And we grab the link to this. Let's see. I would describe it. We can use I don't know. We'll say Python. I don't even know how to tell like what the stuff comes from. Like, obviously this is matplotlib. This is NumPy. I guess this would be built-in Python functions, libraries, modules. Use matplotlib and NumPy to load a wave file and graph it. Okay. Doc strings are docstring. Is that like, you mean like this? So what I've been doing is basically just doing it in Markdown. I don't know what this looks like in any other editor, but then I just change it. So it ends up looking like that. Doc strings. Oh, okay, so I know, I mean, okay. That's what I want. So I saw people talking about a couple different approaches. You know, breaking web files up into segments, processing each one. I don't know, I guess the next, maybe we could look at what kinds of information we can do with the library. Gotta open. No docstring on read frames. I don't know enough about waves. I don't know anything about waves. Read frames. I'm guessing -1 will read all of them. P from string. That's numpy dot from string signal. Yeah, I was just trying to how to kind of like shrink and just kind of move around a little bit. So if I look at this, I mean, it opens up a file for reading. read frames. And then it creates.
What are you afraid of?
Yeah, I don't know any other easier way to do this than just like use the type method or something. Print it out. There's probably some easier way to like hover or something. I don't know. Okay, so this is an array. That's what was confusing me. So it's an array of integers. I just want to see what they look like. Be a bunch of like little numbers. Yeah. Okay. I wonder what that looks like. Okay. So I'm seeing an array of integers. I mean, same thing. Same thing. As to, then this only works for mono files. That's fine. Single wave, okay. I mean, the rest is just plotting. So is it literally just printing all my numbers? So really I could just look at numbers greater than something? So like maybe super naive way of doing this would be, I feel like I've seen some stuff where it's like, geez, I don't know. Lambda x greater than, 10 or something like that. That looks wrong. Let's see. Numpy. Array filter. Filter what? Filter array. Okay. Let's go on the right track. I don't want to do it that way. That looks old. I want new. Okay. R greater than 42. That's weird. I don't quite understand it. So we're saying new array equals array at a boolean. Okay, I see. It's gonna. Okay, this is cool. Okay. That can work because lambda look at each point and see if it's greater than 10. Okay. Do lambda x. Make sure there's anything greater than 10 or less than negative 10. Yeah, because we do see it on both sides, right? I mean, it looks like I could, like, cut numbers greater than 30,000, right? So you say like. Lambda x. Alright. I say bound, whatever. So I'm saying signal at. I feel like I've seen it where it's like. Yeah, I mean, I kind of just want to say like. Signal greater than 10,000 or 1,000 or something. We'll do 20. That sounds good. So won't this return an array and it'll be a bunch of like true falses? Let's see. My hypothesis is this is going to return a bunch of true falses based on whether the item is greater than 20,000 or not. Okay, and I get a bunch of falses. I did 0, and yeah, I gotta worry about negative numbers too. Okay, so yeah, so that's working. Okay. I also want to do like, and signal. Or rather, or. That's weird. Let me just start with 1. So here, I think I could do something dumb like... Dreaded ambiguous. Yeah, sorry, my dad is like texting up a storm. Covering up the chat. I'm getting the weather report from Pennsylvania. Is it getting cold in Atlanta yet? It was high 80s today. I got a sunburn. Jeez. Just see what this looks like. Hey, look at that. That's pretty cool. If you did that. Oh, it's either true or false. That's funny. Yeah, that's not quite what I expected. I want to join. Oh man, a night below 60. That sounds wonderful. Let's see. And call it clicks. So now, this is something that I feel like I should know how to do from the Panda stuff I've been doing. I'm thinking I basically want to join. Do I want to join? What do I want to do? I guess that's the hard part. I need to figure out at this point what I want to do. So for me, I mean, I'd like to find the spaces in between. And clip them out. I'm thinking all sorts of problems with that in meat space. You know, if someone accidentally clicks or whatever, I don't know. Could be awkward, but whatever. It could be amazing. So let's see, clicks where the signal is greater than 5,000. And this is, we'll call this, we call it shelf. This is a really dumb way of doing it. Times -1. I mean, I'm definitely sure there's a way to do that in 1. And then what do I want to do? I mean, I want to find like the minimum number. Let's just try this. The minimum, or rather, yeah, the minimum of high clicks. I want to like find. Yeah, that's a good point. It's a good point. I mean, I want to find the first true item, basically, which is like, I would think it'd be like a find index or something. Let's see, what the heck is... What is this type? Hi. I wanted to see the type of. Nice. I keep meaning to watch those streams. Looks like something's always going on. And if I have a few minutes, then I want to play a video game or something. Or something like this. I don't end up watching much. Stereo. Alright, I did something wrong. Ah, there we go. Okay, so it's a numeric array. So I'm just gonna Google every Friday at 7. Well, you know what? I should host you or something. Do you do it under this name? Okay, I guess I don't know how to do anything. Alright, you know what? I'm going to take a note to host your channel. Host Pi Atlanta. So that way if people, I mean no one will, come to the channel when I'm not streaming, then they'll be one of the ones I host. I also host a live coders group. Default hosting, yeah. I having a hard time doing everything today. Whoa. So I will take that offline and do that while I'm watching Lovecraft Country. Oh man, speaking of lecherouscthulu, Pi Addle. What did I write? I've been watching Lovecraft Country. I haven't gotten very far, but I've been enjoying just seeing the first 2 episodes. And they had shoggoths, which I appreciate. They looked more like this. It's pretty cool. Oh yeah, it's from the show. So not quite what I wanted to see. This is more what I wanted to see, but I'll take it. All right, that is pretty cool. All right, and somehow now I'm setting my wallpaper instead of coding. Hey, it's Sunday. Let's see how it looks. All right. I'll have to find a better one later. Where were we? All right, so we got a notebook. We've got an array of true or false. I want to find the first index. I basically wanted to kind of shrink the graph. The music, oh really? And I haven't really noticed the music. Was it Westworld did that? They had like the weird covers of like Black Hole Sun and stuff playing on the player piano. Like, what is all this stuff? Just close it all. All right. Let's see. I've also been listening to Lovecraft's Monsters, so I've been on a big Lovecraft kick lately. Which, let's see, book. Neil Gaiman had a story in it. Yeah, this. Which is not good, so I probably shouldn't even mention it. I have not loved it so far. Neil Gaiman's story was good. Okay, some of the others have been alright, but yeah. They've had a lot of fish people in it. If the item is larger than X, you can append it to a new array and then convert that array to the WAV file. So I was thinking like what I was hoping to get is basically the indexes. So if I could get this high clicks, which is a bunch of false, false, true, true, false, false, and basically, you know, false, false, true, true. If there's, you know, a true, basically I want to record that index, put it onto, you know, a stack or something, and then, you know, 3, 4, whatever pieces the indexes are, and I could look at like compressing the compressing these ranges. So basically if I have a 3 and a 4 together, then I know I can clip out from 3 to 4, and as numbers get bigger, whatever, then I know I can kind of basically clip between, and so on. All right, episode 4. All right. Oh, I started watching Unsolved Mysteries, so I think we're gonna have to finish that before getting back to Lovecraft Country. Let's see. I feel like I did something where I like joined. You know what? It was I think I have an example of it. Speaking of song, this one's a little wacky. So in here, I think I had here. This is, I think, when we were doing basic stuff. Did I do a join in here? Oh, that's the plot. I don't want chapter 3, I want chapter 2. It would have been near the end. And single if statement. Remove from the current array and then post the new array graph to double check. Yes, I'm not understanding that part. Like, you know, I've got two arrays, and like, I know how like the, you know, kind of old-fashioned ways of doing it, of like, you know, looping through one and then looping through the other one and kind of removing stuff and shrinking. But I was like, I thought there was some way that I could like clip data out in NumPy or NumPy. That was just going to be like, you know, a single if statement. So maybe that's what you're saying and I'm not understanding it. Oh hey, this is a cool way of doing it. So I could get the mean or something. Standard deviation. I'm basically looking for outliers, right? So if I could trim sections between outliers, that doesn't sound too bad. So that's me filtering. And when we filter though, we get true, false, true, true. Oh, I see. Okay, so that's what I was missing. Okay. All right, I think I know what you're saying. Understand what you're saying now. So we come over here. Oop. Come over here. What I could do is where I've got signal greater than shelf. Whatever, let's just worry about the high clicks for now. So here, I could have said, hey, I need you to plot the signal, but only for this array. So we should see those top guys drop out. Oh. I did something wrong there. Array move. Okay. Yeah, that would be better. That would be better than I was just doing. What did I just do? So I said, hey, I said basically only clip the things that are louder than 5,000. It's funny. And what I wanted to do was say, only keep things less than the shelf. And I'm only going to get the top halves, or sorry, the bottom halves. Yeah. It's right there. You're saying, so for item and array, if item is greater than 20,000, remove item from the array. If item is greater than 2,000, remove it from the array and print the array. So that will remove the lines. Yeah, I think we're gonna have to kind of iterate through this array anyway, right? So why mess around with trying to do some filtering like this? Like, what we really need to do is basically just kind of go through here, and it'll be something like for, I don't know, sample for S and signal. S is between shelf if you are less than that or greater than shelf, let's see. We're supposed to be Return after we put the print statement on the new line. I think I understand what you're saying. Let's see. So this is not going to work right. Like we have to kind of zoom in almost to like see what it looks like, but whatever. We'll see it. We'll see how this turns out. Basically change. So I don't know. Cutting equals false. So if we see a change needed, basically there's a state change, then cutting equals not cutting. All right, and then if, we'll just say result equals, or maybe clipped would be better. Clip is a bad word. Clipping is the word I was trying to think of earlier. Trimmed signal, I don't know. Naming's hard. So if cutting, and this is not very Pythonic, is it? Not cutting. If we're cutting items, then we don't do anything. If we're not cutting, and we're appending. This is a terrible way to do this. It's not efficient. But hey, I just want to see if it works. I'm okay with slow. You can iterate on it. This is embarrassing. This is definitely not Pythonic. Let's see. Alright, so let's see what this looks like. Yeah, I don't even care about that. Get out of here. If not cutting. Is false. For S and signal, if signal is greater than shelf, oh, you know, I saw something cool with color. What was it? Gender. Oh. Must have been here. New array dot append signal. Okay. Okay, yeah, it's kind of awkward. So if signal is greater than shelf, you simply put the new array. For S in signal, I think you mean if S is greater than shelf. I think we're trying to do different things. Like I was trying to get the region in between. So I was gonna say basically, if we're cutting, I was gonna say, if we're saying there's a change needed, then if we're cutting, we say start cutting at start cutting at, I don't know what index this is. There's probably some way to get the index. I don't know if that's it. Else. Stop cutting at. Whoa. And if we're not cutting, then we pin the item. So if we run this, if we fix it and run it, oh yeah. Let's see, Python loop with index. Nope. For color and colors, I want the index. Convert to a range. Oh, there we go. And enumerate. Print the index of array.index of item. Oh, that has to do a lookup though, doesn't it? And if I did array.index, wouldn't it find the first index of the item? So if there were duplicate numbers, it would find potentially the wrong one? Or am I misunderstanding that? Am I misunderstanding that? Number and name. For eye and color. Searches for a given element from the start of the list and returns the lowest index. Yeah, so if I had duplicate numbers, then I could potentially get the wrong one. So it's not, I don't love that way of finding the index. But if I could just enumerate through it like this and get the index, then that would be fine with me. Let's see, so I've got the I now. Whoa. Okay. So we need some way to kind of group these numbers because obviously we're seeing a lot of things like close together. So it's almost like we're gonna have a buffer. So I mean, this is not an intelligent way of doing a buffer. But we could say something like a buffer is 500. That way we don't get signals that are too close together. I wonder what the graph looks like. Not cutting. Oh yeah. Why do I need an index? Just for printing. So yeah, you can see from the numbers here, like it spikes really bad. So you know, I like this because it's discrete, but we can see, like, maybe I can print the tail of this or something. This is hard to read. Print. Oh, I guess I didn't print this number. Why is it showing it to me? Oh, because, sorry, never mind. The numbers are too close together. So basically 735, 210, 12. So there's 10, I don't know, what is that, milliseconds? I don't know. 735, 200. Yeah, I like having the index because it like helps me see this. It helps me understand this. Like, look at this, like these are all like super close together in time. We're looking at 735.2s for how long? 735, and then all of a sudden it jumps to 7. So I think that this was a click on and this is a click off because the numbers differ by more than just a few hundred. So it's like I want to have a buffer of at least 1,000 before it goes on to the next click. So I should have basically recorded all of these at as one click, and then everything from 742, which goes on down to 742. There's the last one right there. That should have been counted as one click. So I need to group these. And just having the index helps me see that a little bit easier. So I need to intelligently group these things together, or do some sort of crappy heuristic, like basically store like a start cut index. Sure, start end cut index equals 0. Okay. So, I mean, this is definitely getting fugly. So let's see. I'm gonna call this loud signal instead. So if it's a loud signal, I do want the colors. Yeah, I was hoping to do something basically like if it's greater than X or Y, you know, at greater than 5,000 or less than 5,000, change the color. And I saw doing that by adding a column in pandas, but I didn't know how to do that in just like straight up matplotlib. But it seems like you could pass like a lambda or something for a filter. Then you do like cornflower blue or something, or I don't know. I don't know. That's the only color I know. Blood red, Halloween red. What do I want to do here? Almost kind of just want to say null. I thought I have a null. None. No, if I see a loud signal, if start cut index dark orange, that sounds lovely. Yeah, that would look good. Let's see. Python check none. This is totally anti-pattern here. Inserting nulls into into an integer is none. Oh hey, the idiom is not to set to none. It was not set to none. So if start cut index is not none. Yeah, this part needs to go. All this needs to go, really. I'm gonna rethink this whole section with crappy heuristics. So we've observed a loud signal. I want to say like, hey, if start cut index is what are the cases I have here? Basically, like either we're cutting or we're not. So maybe that's a better way of doing it. So I say if we're cutting, if we're in a cutting section, then if, and then we can probably get rid of the nuns too. So if we're in a cutting section, then if set the buffer to 1000, then if our index minus the start cut index. Why are we doing this except for, so rather than looking for a larger than X, smaller than Y, if item greater than shelf. Oh, because if you look at the numbers, like it seems like it like goes up and down really fast. So if we were able to zoom in on this plot, which wherever it is, then I think we'll see that this is actually not a single line, but there's gonna be like, I don't know, 8 lines or something, like bing, 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 bing. Actually, much more than 8. Maybe we can zoom in here and see. So even though it looks like one line, we can see that I already lost it. Where's the spike? Okay. Yeah, so here's the dog click in Audacity. So we can see that it's actually several samples that both go up and down. And so I can't just say, you know, look for the next lower. You know, it's like, if I was smart about it, I could basically say like, hey, find the first one that's too loud and the last one that's too loud. And then, you know, that's my click, that's my signal. So what I'm trying to do with code is basically saying like, hey, if we're cutting, make sure that, how to say it, make sure that it's not bigger, the difference is not bigger than our buffer. And if it is, let's just ignore that signal and keep cutting. Now, if it's significantly far away, then let's count that as the end of a cut region. And now we know we can start cutting back in. People hear the clicker, then it's fine. The code you're writing is for making sure. Oh, so maybe I misstated the problem. So what I'm trying to do is cut out the sections between the clicker. So if I'm, you know, looking at this waveform, what I want to do is, whoa, cut out this audio and cut out this audio. Does that make sense? So it's like if I need to go to the bathroom or something and I'm editing a video, I could say like, click, go to the bathroom, come back, click, and we're back. Does that make sense? Just because we do that with the podcast a lot. So the goal, the output of this process would be an audio file with these pieces removed. Everything from click to click. And this is not going to work out so great. I can see like even though the click, the thing I like about the click is that it's such a nice spike here, but you can see it's got a tail on it. So yeah, I want to cut items until X appears. So here what I was wanting to do is basically say like, hey, let's start cutting until we see another loud noise that is far enough away to exceed the buffer. So the buffer is just a dumb heuristic, you know, that's just to make sure that basically I don't like, and what's happening now is basically if you zoom in, it's saying, start cutting, stop cutting, start cutting, stop cutting, start cutting. So it's still leaving half of the noise there, and then it's not doing anything in the middle. This is not what I was intending. So if my current index that I've observed the loud signal is minus the starting cut index is less than my buffer of 1,000. Maybe I should give it more than 1,000. Whatever, 2,000, let's see. If it's less than the buffer, then do nothing. Else, what we want to do is set cutting equals false. And I guess I don't really need a stop cut index, right? I could just that. Okay. So stop cutting. Now else, if we're not cutting and we got a loud noise, then we want to set cutting equals true. And we want to set our start cut index equals to our index. All right. And then here we only want to append if we're not cutting. All right, let's see what that looks like. Let's see, I could write this better. If that is greater than the buffer, okay. That's different. Let me try adding another plot. I know there's a way to actually add them both in here. I don't know how to do that. See them both next to each other. Oh, that's interesting. I didn't expect that. Whoa. Here's more what I was kind of looking for, though. That is cool, though. So it's a little hard to tell because the bounds on the graph chart, on the chart changed. So, I mean, this is pretty close. I'm surprised to see this in here. I don't know what happened there. Let's figure out how to get set the boundaries appropriately. So I want them to have the same scale, to make it easier to compare vertically. Matplotlib set range. Okay. Let's see. In my case, I want like this will be the X. I don't really care about the Y. Well, let's leave it. I'm saying okay, yeah. I think we're saying the same thing. 0 and I don't know, 300,000. I don't know if I need to do that again. Whoa. Not what I expected. Oh. So I'm kind of surprised. But, no, I guess that's okay. But, okay, so I mean, this is weird. Let's get the titles in there. So this one is the trim signal, and this one, I have 10,000, 1,000, yeah. I think that I modified something by reference instead of by value, so it wasn't a copy of it. What happened there? My untrimmed signal looks good, actually. My trim signal looks bad. So you're saying the range negative 10,000 to 10,000? Yeah, because I don't really care about that, but I do like to know. Let's see what that looks like. I just want to know that it's kind of hitting the top or the bottom. That's clipping. But yeah, that's much easier to read. I mean, that makes no sense to me. Like, what the heck? Nothing's happening by reference, right? I literally enumerate through signal and I append to trim signal. So in what universe does trim signal end up being bigger? I don't know. Let's see what happens if I do an else here. So what I want to do is basically just show the blank area instead of cutting it out, so it's set to 0. So these should line up the Okay. Like, what happened here? Where did I modify signal even? That's that's weird. It's just not showing because it's too high. It's outside the bounds. I don't know, that's weird. So it looks like basically I didn't stop cutting appropriately. Well, then again, I didn't really make sure that I had it correct number of clips, but I don't understand why my untrimmed signal is modified. Oh, is this a Jupyter thing where it kept? No, I mean I tell it to read every time. Let's restart the kernel just in case there's something cached. Yeah, that makes no sense to me. Well, the untrimmed signal looks great. This I didn't really expect to work. That is strange. So what if I took the limits out? Just wondering if like there's some sort of like weird clipping going on. It's cutting for you repeatedly. Okay, so that looks good. So it's my limits. I guess it's not showing items that were outside the boundaries. Wow. Well, didn't expect that. Let's just go with 50. That's way too big. I could do logarithm or something too to make that easier. Okay. Yeah, so this is interesting. I'm surprised to see a cut there. But and I'm surprised that we don't see a cut here. But whatever. You know, something. I think maybe if we played around with the buffer and stuff, like maybe made that much bigger, we get a better result. Yeah, heuristics, right? So it thought this was a cut section. So I think the shelf was too low here. Just make it, open that up a bit. Yeah, 5,000 is too low. So this looks much more like I expect. So here it came in, boop, started cutting. It cut out the section between, which is what I wanted. Boop. Now here you can see it like it's got a bit of a click in there, which is fine. There was another click, so it cut out this part, and it stopped somewhere in the middle here. So I'm guessing that like got too close to the threshold. So yeah, the shelf should be more like, I don't know, something like that maybe. Yeah, it seems like ML would be good at figuring out these numbers. Isn't that kind of the deal? It's like, okay, we know the algorithm, but we don't know the parameters. Machine learning. Yeah, 20,000 would probably be better. Okay, so I'm pretty happy with that. So clip this part out of the middle. I am kind of surprised to see it clip this stuff out, but I don't know. I'm okay with that. Let me try doing another test file that actually is a little bit easier to deal with. Let's see. Where's my clicker? So now if I'm just doing regular talking, then I want this part cut out. And now we're ready to clip back in. So now we're back in. So in this case, I just want that middle section cut out. Guess without the clicker. Oh wow. Okay, so I mean it's not great. This is that's what I want to cut out, but it got too much at the end. And we have parts of the actual click itself in the audio, which is not really desirable. Yeah, so I don't know. Play around a little bit more with this stuff. And then we'll try exporting the audio file. Oh, that's not what I meant to change. This is the number I meant to change. Yeah, 20,000 like you said. So that's good. So this is over 20. Like, so if we were to zoom in on the audio file. I don't really know how to use Audacity very well. I want to zoom in there. There we go. So you can see where it's got like a click sound. Right. So with machine learning, I will want to kind of recognize this pattern with the click and the clicks are probably similar. You know, depending on how you click it, it could have a different period, but basically I want to see this pattern. And we can see that parts of it aren't very loud. Most of it is. So with my buffer size there, I wanted to kind of say like, hey, you saw something loud? Don't look for anything loud. Basically skip over this. Don't look for anything loud again until it reaches that threshold. Maybe we can do like, if we set this to like 30,000 or 25,000, see what that looks like. So here I would expect to still have a little bit of the juice. Did I forget to set a variable? Like I expected to see this stuff at the end here. Click on, click off. Yeah, I don't know. Brought up the while item less than shelf. While item is less than shelf. Oh, I see what you're saying about less than shelf. Yeah, so yeah, the heuristics just aren't great. Like, so we come in here like, whoa, that's too far in. Just zoom in there. There we go. Just zoom in there. So I kind of want it to basically, we could backtrack a little bit to find this, but find the first spot that hits, like, let's say here, you know, 0.7. You hit 0.7, okay. Then it can get louder from there. And I don't want it to count as a stop click. It just, after it reaches a certain amount of time. So we'll keep looking. The wow will keep looking. Okay, I see what the wow. I see what you mean. Okay, yeah, I totally see what you mean. I think. Let's see. With the while loop. Yeah, I guess I don't understand how to fit that in there. Just not understand what you're saying. It's gotta be frustrating for you, sorry. It's like I want to advance this. You're saying maybe doing a while loop instead of the for, so we can kind of fast forward with the inner loop. So like I equals 0. While I is less than signal length of signal, and S equals signal at I. So we say, okay, we got a loud signal and we weren't cutting, so let's start cutting. So here saying, instead of keeping a variable here, this is where you would start fast forwarding. So we could even say something like, let's get that out of there. Let's get that out of there. So I don't even care about cutting equals true. Basically, we saw a loud signal and we weren't already cutting. So I almost want to say, like, you know, remove the last 500 items, because that, you know, we'll worry about it later, but basically the loudness leading up to the actual click that we hear, we're going to start cutting a little bit before, and then we could do something like, say, hey, let me do this right now while I'm thinking about it, so I don't get an infinite loop. I plus equals buffer. So, like, don't even look at anything until after the buffer, which should get us past the click length. And then from there, we'll say while I is less than length of signal. Is this what you're thinking? And signal at I is less than the less than the shelf. I plus plus. So this is kind of what you're thinking. Quiet parts. And then even that, like, I just have to kind of it's negative shelf, right? Okay, cool. I plus equals 1. Okay. I like that better. Increment y. So then I don't care about this. Well, I guess, I mean, if we want to be able to see this better, for now we can just do that. And then that. Yeah, that does read nicer. So we get the signal. That should probably be a function that we use twice, but whatever. If we see a big number, then I plus equals buffer, and then oh yeah, so this is going to clip stuff out, so whatever, let's just not worry about that. I was thinking the code you had before, but with a while loop inside of the loud signal statement. Yes, I think that's kind of what I got here. Is that similar? So basically, if you see a loud signal, jump ahead of the buffer and then start looping until you see another loud signal. And when you see the second loud signal, then I could jump ahead again in the buffer. So when it's done, I plus equals buffer, and then this should only be the else, right? See what that looks like. You can have the cut. Okay. So here I think the buffer's not big enough. So there was a click and a click and that was too loud too. So I think in this case we just need to increase this buffer size. Heuristics again. Better. Yeah, that looks pretty good actually. So we got a little bit here, which I think this has to do with that pre-signal. So let's see, buffer is not a good word for it, so maybe call this like click echo. All right, cool. Well, hey, hope you have a good one at work, and hope you can start getting those normal hours, man. I hate that you're still doing that. Buffer. But yeah, I'll get this posted up on GitHub or something and have some fun with it. I'll try exporting the audio, see if it actually exports and does what I want. But thanks for all the help. I really appreciate it. That was really awesome. I would not have got through it without you, for sure. Let's see, pre-click echo. So this would be how far we kind of hop back. Which would be something like, oh, that seems like an awful lot. Trim signal at I minus that. I just want to chop off everything after. Python. Yeah, let me grab a to-do on that too. Kaggle notebooks. Yeah, now that I know more about what notebooks actually are and stuff, I'll have a greater appreciation for those things I've seen up there. Yeah, great idea. All right. Let's see, Python, remove from list. Let's see. Oh, slice list. That's what I want. Okay, so I want to say basically trim signal equals trim signal at something like something like that. Oh, that looks beautiful. There's a lot of space there in between, but I'm okay with that. All right. Right. Wave. Okay, that was longer than I expected. And just do wave.right. Let's see, trimmed. Right only mode, sure. Not correcting. Is it just... Okay. Okay, so I need to basically say, hey, make this a numpy array. If I'm reading this right, which probably, you know, who knows. Okay. Now it's a numpy array, and then I can say 2 bytes.
I don't know what y'all think, but I think that's pretty.
I guess that worked. Let's try that again. We'll actually delete the output. I don't know how to tell if it's running or not. Done. To like close it. Oh. All right. So if I'm just doing regular talking, then now we're back in. Wow, it worked great. That worked great. 7 seconds. So if I'm just doing regular talking, then now we're back in. Wow, so if I'm just 14 seconds. Talking, then wow, okay. I mean, it worked.